Okay, if you haven't already done so, I want you to take out your 5C notes. We're going to finish up the last of the slides that we left blank the other day so that we can fill those in, and then you'll get a chance to work on the study guide and just do the best that you can. Okay, we will go through this the next time that I see you, and I think we should be in decent shape. And for those of you that get it, please help everybody around you. Okay? All right, now we're going to do bromine first. Now remember, the first two things that you have to figure out when you are doing the electron configurations is that you have to figure out how many electrons you're dealing with and what section it ends in. So if we come over to bromine, and I can't write on this screen, so it's a little bit tough to see, at least I don't think. Let me try one thing. No. Here's bromine right here. Okay, bromine is going to be in the 4p block. Okay, and if you look at bromine, it is the 35th element on the periodic table, which means it's got 35 electrons. So if we come over here, we need to remember that we've got 35 total electrons, and then it's going to end in 4p. So what we have to do is, up to that point, we have to map out everything up to that point. And orbital notation, just as a reminder, is going to be the arrows. And when it's on the test, I put that in parentheses. So let's start at the beginning, and remember, we get this order from either the diagonal chart or the periodic table, but we start with 1s, then we go to 2s. Now for the p's, there are sets of 3 orbitals, so we have to draw 3 lines. Then we're going to have 3s, and we're going to have 3p. Okay, now when you go down to the next line, the next thing that the next one that you come up with after 3p is 4s again, but after 4s you get that overlap, and the one that comes after 4s is 3d. Now we haven't seen this yet, but the d's, remember, the d block has room for 10 electrons because there's 10 boxes, or 5 orbitals. So we write 1, 2, 3, 4, 5, and they are all considered or part of the 3D block. Then we got to go back and do the 4Ps. When I say go back, I mean the energy levels overlap. So we've got 1, 2, 3 for 4P. I'm just going to put a line there just to separate them. Okay, now we got to fill them in. Now the off-bal principle says that we fill them in starting with the lowest energy first. So I put 2 in the 1s, they're facing opposite directions. One facing up, one facing down. That just indicates opposite spin states, which meets the Pauli exclusion principle. Okay, 2s. Now Hund's rule was kind of ugly, but what Hund's rule said is when we fill one of these that have the same energy level, we put one facing the same direction first, then we go back and we double them up. Okay, 3p, we're going to do the same way. Okay, we fill 4s. Now when I do the d's, I'm going to do the same way I did the p's to follow Hund's rule. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I've mapped 30 total electrons because I have 30 total arrows. I've got 5 left. So when I fill 4p, this is how it's going to go. 1, 2, 3, 4, and 5. So there is in essence an empty space right here where there is not an electron, and we're going to figure out why that governs things a little bit later. Okay, so on this one, that's my orbital notation. My electron configuration is going to look like this. And this is the superscripts. Okay, so it's going to be 1s2, 2s2. Now all this 2 is telling me, it's not squared, it's just telling me how many electrons are in that section. 2s2, 2p6, 3s2, 3p6. Now why does it get a 6? Because there's 6 total electrons in those 3 orbitals, or if you look at the p block, there's 6 boxes there. Okay, 4s2, we keep them in the same energy order, so I'm going to go 4s2, 3d10, 4p5. Okay, now if you go to the periodic table and you go to the 5th element in the 4p block, okay, so here's the 4p, 1, 2, 3, 4, 5, that's bromine. Okay, right there. So you can also use that to work backwards, what you're going to do on your homework. If it ends, let's say you had one that ended in 5p5, okay, then the element is iodine. You can just count over that easily. All right. Okay, so, and that's what this is showing you over here. This is just showing you the pattern for the halogens. where you have all of them will end in P5. Fluorine is the fifth element in 2p, chlorine is the fifth element in 3p, bromine 4p5, etc., etc., etc. Okay? All right, now for argon is the next one that we're going to do. And again, we still have to figure out how many total electrons we're mapping and what section it's in. So here's argon right here. It's going to be, this is 2p, so it's going to be in the 3p section, and there are 18 total electrons. If you don't know where I'm getting 3p and 18 electrons, make sure you ask someone when you guys get a chance to work together and work on this. All right, so I've got maybe 18 electrons, and it is in the 3p block. So I'm going to start the exact same way that I did before. I'm going to have to fill everything up to 3p. So I've got 1s, 2s. I've got 3 for 2p because the p is a set of 3 dumbbell-shaped orbitals. If you look over by the Respect bulletin board, there are those 3p dumbbell-shaped 3D regions to represent all of those. After 3p, we've got 3s. I'm sorry, after 2p, we have 3s, and then we're going to have 3p. Okay, I need 18 total, so this is how I'm gonna fill this up here. I'm going to put 2 in the 1s, 2 in the 2s, 1, 2, 3, 4, 5, 6 in the 2p. So far I've mapped 2, 4, 6, 8, 10. I'm also going to do 2 more in the 3s. That gets me to 12. And then I have 6 left in 3p. So I'm going to fill it according to Hunt's rule. I'm going to put 1, 2, 3, 4, 5, and 6. And you'll notice this fills that last sublevel. Okay, these are all the noble gases, and it shows that most of them, with the exception of helium, which ends in 1s2, they all end in 3p6. Part of the reason we know the noble gases are not very reactive is they already have all the electrons they want. They're what I refer to as happy, and it's just because it's filled. There's no holes, they don't have any extra ones. We're going to talk more about this in further sections, but essentially that's what we're going for on this one. Okay, now this is the orbital notation, which again has the arrows. Now let me do the electron configuration, which is going to be the superscripts. This is going to be 1s2, 2s2, 2p6, 3s2, 3p6. Okay, and that's it. I mean, once you figure out, and again, if you had to work backwards, you know, if I gave you an electron configuration that ended in 2s2, 2p6, you should also be able to figure out that that is neon. Okay, there's one more component to this, which is essentially shorthand, and that is noble gas notation. And it's a shorthand for larger atoms. We know that noble gases are complete. They don't want to give away their electrons, they don't react, so it makes them noble gases. So it's kind of a shorthand, whereas if this would be sodium's electron configuration, right? 1s2, 2s2, 2p6, 3s1 for a total of 11 electrons. Okay, nothing shocking. If you look at what is in brackets right here, this is neons. It's always neons. So we can abbreviate it by doing neon 3s1. Magnesium, we can do the same thing as neon 3s2. All right, now you always go to the last noble gases symbol. So if I back up to show you the last two for just a second, if I look at bromine, okay, the last noble gas before bromine was argon. So that's how I'm going to be able to abbreviate these. So let me show you how I would do that. If you go back up to bromine for just a second, this right here is argon's noble gas configuration. So a shorthand for bromine, I'm going to do this out to the side here. Now I'll do it underneath. I think I can fit it. Would be, let me come back here. Okay. Would be argon 4s2, 3d10, 4p5. Okay, that would be the noble gas configuration. Now, if this part doesn't make sense, I promise we'll get you there. Don't worry about it. Okay, so if we look at argon, let's do one more. The last noble gas before argon, you can't just put argon in parentheses. That's too easy. Because valence electrons are still the outermost ones. So neon is the last one. So just to show you what that would look like, this right here is neon's configuration. So the noble gas configuration for argon, we just wrap up the last noble gas because they're not going anywhere. We just show the valence electrons that are the outermost shell, which is 3s2, 3p6. Again, do your best on the study guide. If the noble gas is the only thing you're stuck on, don't worry about it. I'll explain it the next time that I see you. Okay, be good for the sub. I hope that helps.